right, so I'd like to talk to you about the metric system. This is chapter 8 in the applied math class. The metric system, the basic terms that we use in this class will be the meter, which we use to measure length, the liter, which is used to measure liquid capacity, which thankful to the pop bottling company, we know what a liter of pop looks like, so that helps us kind of wrap our mind around what that looks like. But notice when you buy a liter of pop, that's a liquid measure of volume, so how much is in a container. So liter. Gram, a gram is a very tiny measure, but it measures the weight of something. It's what we'll use instead of our typical pounds in the old customary unit, but grams in the metric system. And then Celsius is what we use to measure temperature in the metric system. So to sort of wrap your head around those basic terms, it will help if you know that a meter is just about a yard. And I don't know at your house if you have meter sticks or yard sticks, but everybody used to have a yard stick, you know, about yay long. And to note, they say that this came from, a yard is like how far it is from your nose to your outstretched hand, so that's about a yard. If you've ever measured fabric, if you are a seamstress or dabble with that, if you take fabric and you kind of move it out this way, you can kind of tell about what a yard is. And I think it was from a man's arm, so maybe a little bit further than I'm going, but it's about a yard. So we kind of have that idea in our head, and we've had the yardsticks. Well, the meter stick is a little bit longer. It's about 39 inches. So a yardstick's 36 inches, and a meter stick's a little bit more than 39 inches. So just a little longer than our yard. So get that in your mind. Then for kilogram, gram's so tiny, it takes 1,000 grams to weigh even a kilogram. So it's pretty light measure on that side. So 1,000 grams or a kilogram is about, and the squiggly line means it's not an exact, there's no exact conversion there. So it's about approximately 2.2 pounds. So if you can kind of envision that. A liter, we talked about a liter, you know, we kind of all know what a liter looks like now because of our liter of pop analogy. So if you can think about what your liter of pop looks like, that's about a quart in the Old English measure though, about a quart. If you can vegetables, we all know what a quart jar looks like. I don't know if you do or not, but I think we all know what the liter of pop looks like, even probably better than the quart. But anyway, those are our basic terms. Now, we're going to have a formula for Celsius to help us convert back and forth between Fahrenheit and Celsius later. But for now, our focus in the first section is to convert between the prefixes in front of these basic terms. So we have this handy way of converting in the metric system by adding prefixes. So if we add the prefix deci means we have a tenth of any one of these. So this is dividing as we go down the list. A deci would be 1/10 of a meter, like a decimeter, we'll call a dm, is 1/10 of a meter. So you take that meter stick and divide it into 10 equal parts. It's about this long, so it's not that big. Maybe you would compare it to inches, a little more than inches, but a decimeter. A deciliter, we don't really use that often, so, but a deciliter would be take your liter of pop, divide it into 10, you'd need a little bit of drink there, a tenth of your liter. And a decigram would be a very tiny measure. All right, so if we go to centimeter, we're dividing it by 100. So it's a tiny measure, and it's probably closer to that inch measure I mentioned. And then milli in front of any of these means 1/1000th. So these are the tiny measures. Now as we go up the scale and multiply, a deca, D-E-K-A, a deca is 10 times any of these. So a decaliter would be 10 liters of pop. If you bought 10 liters of pop and you poured it all into a bucket, that's what a decameter would look like. Now to differentiate between deca and deci, there are two D's on the list that we use. We call deca with a D-A and deci with just a regular D. So a DAG is a decagram, where a DG is a decigram. So that's our differentiation. Going on up the scale, hectoliter would be 100 liters, a hectogram, 100 grams. We don't say those that much though. And a hectometer, HM, would be 100 meters. And then the last one that we regularly use is kilo. kilometer. Now we use that one a lot. A lot of times we say a kilometer, and it's the closest measure to a mile. So a kilometer or a kilometer, whichever way you want to say it, is a km. A kiloliter is a kl, and then a kilogram. We do use that measure. A kilogram comes up in different measures a lot, but a kg. All right, so let's talk about how we convert between these units. And you also might notice, if you are following along in the book, there's a lot more prefixes. These are just the commonly one used that we'll use in this course, but there's a list of others. Because of technology and the computer, we now know about nano, gigas, megas, terabytes, Yoda. So again, on page 438, if you just want to look at that, there's many, many, many other prefixes. Then we have tiny measures like nano, and micro. I was trying to look at some of them for you. But there's all kinds of prefixes. These are just the ones that we commonly use and we'll use in this class. All right, so to convert between this scale, say we're going from 3.2. Let's do an mg, which would be a milli with the base unit gram, a milligram, and we want to convert that into regular grams. How many grams is 3.2 milligrams? And here's how I do it. I say as we're going up the scale, anytime you're going from a smaller unit to a larger unit, up the scale, I move my decimal to the left. If I'm going down the scale, I move my decimal to the right. So to go from milli up to just base gram is 1, 2, 3 moves up. Going up moves my decimal to the left that many places. So 1, 2, 3, fill those in with zeros. 0.0032 would be your answer for that. Okay, let's do that again. Let's say we've got just regular 4 centimeters. And we're going to make that a DAM, a decameter. So we're going from centa, and our measure is in meters, and we're going up to the decameter. So same units, you know. So from centa is 1, 2, 3 up. So again, I went 3 up, but if you don't see your decimal, remember it's understood at the end, 1, 2, 3. And then fill in the zeros for any places there. Okay, another example. Let's say we've got 52 kiloliters, and we're going to move that down to hectoliter. Just one move there. We're going from kilo to hecto, just right below it, but that's a one move down. Down, moving my decimal to the right that many places. My decimal is at the end if I don't see it. So 1 to the right, I'm going to add a 0. It's 520. Okay, let's do hectometer. Let's say we have 0.07 of those hectometers. That's here for hecto, and its unit is in meters. We're going from hectometer. Let's go to a decimeter, DM. So from hecta to deci, 1, 2, 3 down. Down moves the decimal to the right. So 1, 2, 3. I'm going to fill in with a 0. My decimal is now at the end. That's a non-essential 0, so just call that 70. All right, let's do 5 liters, and let's move that down to centiliters, a CL. So from regular liters to centiliters is 2 moves down. So find your decimal. It's at the end here. Go 2 moves right. Down is right. Moving up the scale, we move left. Some people will move this scale horizontally and say moving right moves your decimal right. That's fine too. You may see that in another class or in a program that you get in where you're using the metric system. I've always used my scale vertically, but it's basically the same. You know, if you were to pivot this thing and put meter, liter, and gram, those are your 3 basic units that we convert, and then put your prefixes over here, start with deca, centa, milli, and then you're just writing the scale, but I've pivoted it sideways. and then I've got deca, hecto, and kilo. So now you can say moving right moves the decimal right, which might make more sense. It's kind of your call there. But let's say when we move on the scale right, we move our decimal right. So seeing it horizontally, let's say we got 3.2 decimeters, and we want to move that to centimeters. So deca to centa, that's one move. So one move right moves my decimal right. So one move right, decimal right, 32. Just another thought there in case you see it that way or you've seen it that way in your past. Let's say we have 5, let's do 0.052, and we have decagrams. The AG would be decagrams, and we want to move that to milligrams. So from deca, that's up here or to the left. Deca, that's one move. The basic units counts as a move. 1, 2, 3, 4. I'm going to milla. So 4 moves right, so 4 moves right with my decimal. That would have been down on the other scale or right if you sit horizontally, but it's 4 moves, so the decimal also moves 4 places. Now if the 0 winds up in front and the decimals move to the right, just leave that 0 off. That's 520. Now what I'll do in the next lecture is I'll talk about the next section in the book where is if these are square units, you're going to move more places. So just remember this was linear moves where you just to the first power here, a decimeter, centimeter, both just regular linear first degree units, so we move one place. But if we were doing square units or cube units, we're going to move more places for each move. So just be aware of that. That's coming later in the sections.